Hello, this is Mr. Stansbury. I'm going to take you through the notes on the least squares regression line. At the end of this, you should be able to say, I can calculate and interpret the line of best fit for a data set. Okay, so first thing, we can calculate the line of best fit for a set of data by a method called linear regression. Okay, and I'm going to show you how to do that on our graphing calculator here. Okay, the linear regression method we are going to use is called the least squares. Okay. So, let's see. Example 4. In the table, there is a population data for wild hedgehogs and frogs living in areas of Ireland. Okay, so here's the hedgehogs and here's the frogs. Okay, first thing we're going to do is construct a scatter diagram. Okay, so here's our hedgehogs, here's our frogs. Okay, the hedgehogs need to be up to at least 61, which we've got there. And then the frogs have to be up to 102. So we're just going to simply go through and graph each one of these points. So we've got 44 and 58 is roughly right about here. And let's graph the rest of those. Okay, so here's roughly what the scatter diagram looks like. Looks like it's pretty much a linear graph here for the most part. Okay, so now what we're going to do is we are going to find the least squares regression line, and we're going to do that on our graphing calculator. Okay, so we've got our two sets of data. This is our X, this is our Y. This is going to go in list 1, and this is going to go in list 2. Make our life simple. Okay, so to do that, if you remember, we push stat, and we are going to edit. There's already data in there, so I'm going to highlight list 2, push clear, go down, and it disappears. And then I'm going to go up and I'm going to highlight list 1 and push clear, and all of our data is cleared from all of our lists that way. Okay, so now we're going to simply enter in 44, 18, 27, 61 all in list 1, and then 58, 120, 89, so forth and so on in list 2. Okay, so I went through and put in all the data here. And I specifically left the last piece out just to kind of help you out. So when you put the data in, just put the data in, and then you push enter, and it will go to the next cell down. So I did 72, I push enter, and now I can do 70, push enter, and there's all of our data. Okay, so to find our least squares regression line, we're going to go back into stat, and we're going to calculate, and we're going to do our linear regression here. Okay, like we did earlier. So lin reg. Okay, push enter, and all of our X is in list 2, our Y is in, X is in list 1 and Y is in list 2. Go down to calculate, and it gives us this here. So you remember from before there, that gives us our R value. This tells us that it is a strong negative linear strong correlation. Okay, now this here is our least squares regression line. So if you notice this, y equals ax plus b, a is negative 2.159, blah 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 blah, b is 151.82, blah 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 blah. So our equation is going to be y equals negative 2.16x. So we get y equals negative 2.16x. And then we're going to have to add in the b, and the b is 151.8. We'll call it plus 151.8. This here is our linear regression, right? And really this y is the number of frogs, and this x is the number of hedgehogs. But this is our least squares regression line. Okay? State and interpret the slope and y-intercept for the regression line. Okay, so the slope is negative 2.16, and then the y-intercept is going to be this 151.8, because if you plug in 0 for x, that will go away, and we're left with 151.8 would be our y-intercept. Okay, estimate the number of frogs if there were 10 hedgehogs. So all we'd want to do is, with this equation here, plug in 10 for the x, right? Because x, the hedgehogs are x, so we do negative 2.16 times 10 plus 151.8. We could do that on our calculator, or we can just say, oh, look, if it's multiplied by 10, just move the decimal over. So that's going to be y equals negative 21.6 plus 151.8. And then we subtract those two. I'm going to use my calculator anyway. Second quit will get us out. So we do 151.8 minus 21.6. And that gives us 130.2. So about 130 frogs. Okay. And then estimate the number of hedgehogs if there were 45 frogs. So for the frogs, if you'll notice, is in the y portion. So we're going to put 45 in for y. So we would do 45 equals negative 2.16 x plus 151.8. And then now we want to get, let's do this. Let's subtract 151.8 from both sides. Right? And that will, let's see, negative 2.16x equals whatever that is. Ooh, wait, you know what? We've gone, before we do that, let's take a quick video comedy break.
Guy had an active walker, too. He had a handbrake on the walker. How fast are you walking? I thought walking was the problem. That's why you got a walker. You got a walker. Now you have a handbrake on the walker in case things get out of control. Because you never know when you're walking along a highway, someone sneaks up behind you, bumps the horn, you get all crazy legs and river dance off into the woods.
Okay. So we were taking 45 minus 151.8. And that gives us negative 106.8. Negative 106.8. And then we divide both sides by, that is a 216, negative 2.16. 2.16. Divide by negative, don't push subtract, put the negative, 2.16. And we get 49.44, so we're going to have to go with about 40, what did we say? I can't even remember. 49.44. So we're about 49 hedgehogs. Okay. And then how reliable are your estimates in D and E? Okay, let's see. So let's see, for D we had 10 hedgehogs. So that officially is extrapolation because that's outside of our lowest X data point. But it should still be, it should feel like it should be pretty reasonable here. Okay, and then E was if there were 45 frogs. So there's 40 and then there's 45. So that's within our lowest number of frogs. So that's actually interpolation. So that one should be pretty reliable as well. So they both should be pretty both should be pretty reliable. Okay, both should be pretty reliable. And that is it. Okay, so if you have any further questions at all on least squares regression line, please feel free to ask. Thanks.